So this presentation is about planting trees in the prairie. I'm hoping to emphasize the challenges of planting trees in North Dakota to drive home the idea that trees really need to be cared for in this landscape. I'll be talking about some of the foundational pieces of information to help us focus on what needs to be done and why. And this is in order to have a more successful planting. This should also demonstrate kind of the foundational issues that tend to influence tree health in our landscape. And most of it is built around conservation plantings and windbreaks, but it's also applicable to landscape trees. So throughout this presentation, I'll be talking about several topics in order to develop this understanding. And we're going to start with kind of why are trees important, kind of the foundational framework for North Dakota. And then we'll talk about the history of conservation plantings and some of the old thoughts that are evolving, but where most windbreak plantings originated. And then characteristics of a planting site, which is fundamental to the success of any tree growth. And then some of the important concepts that should be considered before planting. Also, the basis of what species to choose. I'm not going to give you species to choose, but sort of some of the framework you need to consider in order to select tree species if that is what is being accomplished. And then some of the potential future climate challenges that we may or should expect to see in the future. These concepts are applicable to all trees, but I have again focused more on conservation plantings, but it's applicable to landscape plantings. In most landscape plantings, it's much easier to tend to kind of the fundamental issues that we'll see, which are primarily watering. In a landscape situation, that's easy to control, not so much in a lot of our windbreak plantings. Planting trees in the plains to support this lifestyle is no less important today than it was 100 years ago. There are an assortment of reasons for this promotion, but the foundation of these is firmly grounded in creating screening. More recently, it has become clear that these semi-natural components of our landscape also produce additional benefits that we think of as ecosystem services. So screening, shading, they perform an aesthetic purpose, are all ecosystem services, but there are many others. These services are categorized into provisioning, which can produce a product like fuel wood, regulating the climate around us, supporting, which promotes soil development or nutrient cycling, so stabilizing soils is one of those supporting characteristics, and then the cultural, which we look at as kind of the educational or aesthetic component. Now, some ecologically focused benefits are the retention of soil by preventing soil erosion at the soil surface or by catching the blowing soil from fields on leaves. Blowing soil eventually ends up back on the ground under these trees as it is rinsed off by rainwater. Trees can also be planted strategically to reduce standing water through transpiration, which is the movement of water from the soil through the roots to the stems and ultimately back out through the leaf surface to the atmosphere. You can put trees in a moist location in some circumstances and reduce that moisture. Other ecological benefits are those relating to increased habitat for birds or beneficial insects, such as our pollinators. I would guess we could all come up with some personal benefits that are equally as important that aren't mentioned here. For North Dakota, one of the fundamental aspects of tree plantings is to establish windbreaks for economic benefits related to agriculture, primarily soil loss to wind erosion. The Great Plains Initiative 2 project was recently conducted to identify windbreaks in the plains. This project used remote sensing to identify the characteristics of conservation plantings based on their aerial perspective. The project also identified areas of the state with the greatest need for soil protection, identifying over 500,000 acres of highly erodible soils in North Dakota. The location of these soils would benefit from either the establishment of windbreaks or the renovation of existing windbreaks in a time when many windbreaks are being removed. Now, this is important because there are on average about 4.7 tons of wind-eroded soil loss per acre year in North Dakota. Losing soil to wind erosion exposes lower soil horizons, which frequently brings lime and salts closer to the surface. Establishing windbreaks in such areas becomes complicated by this soil loss process, but it also very much demonstrates the importance of having trees in those locations. Now, additionally, windbreak renovation is as important as new plantings because the decline in windbreak tree health increases the porosity, decreasing their effectiveness, which allows increasing wind speeds and more loss, less soil deposition, or even less snow accumulation if that's the intent of the planting. Okay, I wanted to take a little time to look at the origins of windbreaks since much has changed and it may put light on many of the topics here. Now again, all this information is relative to planting trees. I just wanted to put more emphasis on the origins of designing conservation plantings. We all understand why trees became a valuable component to add to our landscape. But why did windbreaks evolve to the linear structures we see today? Now, of course, there's a significant logistical and financial advantage to this structure, but what else? So much of the understanding we originally applied to the plantings of windbreaks or shelter belts came from the methods used in plantation forestry. In plantation, trees were planted at high densities, maybe 6 to 8 feet like we've seen in historical windbreaks, all with the intention of encouraging rapid height growth and then integrating intermediate management activities to thin those stands as growth slowed with a decline in growing space. Now, this intermediate activity is a drastically different attitude as compared to what we see with windbreaks. Now, despite the value of a windbreak tree being comparable to the product-focused trees in plantation forestry, we still rarely put in the energy for managing these trees. Now today, we have adjusted planting densities to perform varied tasks depending upon the planting objectives and the species used. The densities have been redesigned to consider future growing space to support better resource availability without intermediate management activities. Now this is a logical trajectory, but doesn't consider how the planting influences the microclimatic circumstances that develop. Developing a microclimate within the canopies of closely planted trees influences the humidity around the foliage, allowing for better control of foliar water loss. Now this very likely would allow the tree to maintain a conductance during conditions that open-grown trees could not. So maintaining conductance allows for continued photosynthesis and more opportunity for a responsive carbohydrate allocation that may offset the challenges of a more variable set of climate conditions and soil moisture conditions. So only time will tell us how increasing these plantings spacings will really affect tree health with potentially a much drier climate in the future. So now we've looked at the common objectives and some of the historical logic to conservation plantings in the prairie. We also need to think about some variables relative to the location we plan to plant in. In many cases, the location of a windbreak is predetermined by the objectives. Recognizing the following site variables will help understand the variability that may occur in future growth because of putting in a very linear structure and not considering all the site conditions. So what are the actual conditions of the site we are interested in planting? In North Dakota, there are a few important things to consider. Now this ends up being a combination of several items made up of the climate again, soil characteristics, the topography of the site, and other biotic organisms. The site becomes the sum total of the climate, soil, topography, and a host of other biotic and abiotic interactions. Now, when we are talking about planting in a landscape location or an agricultural setting, we should be assessing these components in order to create a better growing circumstance. While doing this, we are always trying to address the fundamental resources needed for growth, which are water, light, and nutrient. And I would put them in that order because I think water is really one of the limiting variables to planting in North Dakota, and we'll discuss that in more detail later. One of the primary resources that is necessary for growing a tree is something that we can control in most landscape situations, and that's water. I think we all understand that water is a necessary resource for growing plants. So how much water is available in the North Dakota landscape? Understanding some things about the North Dakota climate can help us better understand this question and why care and maintenance are fundamental to tree plantings in this state. The climate is the long-term average of the weather, which is a combination of the temperature and precipitation, which is the rain or snow. Of course, how it's distributed across the year. Almost the entirety of North Dakota has a climate described as humid continental. This is a climate system that has 4 distinct seasons which receive precipitation across all of them. Now, what's important to understand about this climate is that there is a distinct difference in the amount of precipitation that falls across the state annually and how it differs from a naturally forested landscape. So I included a figure here that shows the annual precipitation from western North Dakota moving across to east central Minnesota. I wanted to demonstrate the change in precipitation across the prairie and into a historically forested landscape, which is Grand Rapids in this case. As you move from west to east in our humid continental climate, more annual precipitation falls, which supports more leaf area. It's important to understand that trees contain more leaf area than any grass community, and therefore have evolved on sites that can support the transpirational water loss necessary for growth. When wanting to establish trees, understanding the distribution of precipitation in the North Dakota landscape helps stress the importance that planted trees need watering to maintain their health. In a general sense, there is nowhere in North Dakota where planted trees wouldn't benefit significantly from supplemental watering. North Dakota did not historically support tree growth outside of those locations in the landscape that remained wet based on topography. Locations with higher slope angles and riparian areas have the natural tree growth because water was concentrated in these features. Receiving the amount of precipitation we experience here during the growing season supports grasses and forbs, with the drier western side of the state consisting of short grass prairie and the eastern side consisting of tall grass prairie. Generally, the total annual precipitation in the eastern side of the state is around the minimum commonly found supporting tree growth. When we add in the historical fire regime that came with the prairie landscape vegetation and native large mammal grazing, trees simply had limited opportunity to develop outside of those places that concentrated the moisture. Now you can see in the upper figure that it's not only the amount, the timing of precipitation that matters. These are the same 3 locations from the previous slide, showing a steady increase in precipitation through June. After June, there's a much less growing season moisture as you move west. Now this is important because plant development through this period, particularly trees, requires the transpiration of water from the soil through the leaf. And having so little water means the photosynthesis becomes limited. Today we have almost eliminated fire as a disturbance mechanism on our landscape, creating conditions that are conducive to allow tree establishment naturally. Locations where they can establish, they are limited in their productivity and can easily become water stressed. We see the consequences of this in the natural expansion of many of our native forests in places where agriculture and land use don't inhibit it. The difference is that the rates of growth are much less than you would find in more suitable parts of these species' niche. Now, as an example, the rate of growth in naturally growing ponderosa pine in Oregon is twice that of planted ponderosa pine in North Dakota, and also in the naturally growing ponderosa pine in North Dakota. Due to the historical climate and glaciation, North Dakota has an abundance of fine textured soils that are generally difficult soils for trees to grow in. A soil that is composed of tiny silt and clay particles has very little airspace as compared to the larger particles of a common forest soil, which would have a higher content of sand and the parent material where that sand came from. So soils made up of a higher component of silt and clay have slower water and oxygen diffusion, and increasing the difficulty a tree would experience extracting water and oxygen. Fine textured soils mean water is able to stay in the soil longer, which requires trees to work harder to pull it from the soil particles to their leaves. The response to this is often decreasing growth as the higher tensions of the pathway of water from the soil to the leaf surface lengthens with tree height. As for oxygen, fine textured soils limit its presence, allowing for rapid depletion when the soils are saturated. Soil saturation causes normal root functioning to deplete oxygen, reducing growth and potentially causing tree mortality. We saw a lot of this following the extremely wet fall of 2019, which was followed by the heavy snow which insulated standing water on the soil surface throughout a good portion of the winter. Now, another important silt clay soil issue is water infiltration and drainage. Clay and silt particles require a fair amount of moisture in order to become wet, but once it's wet, it will hold that moisture well. Because this soil holds moisture well, it also doesn't drain or move water through the soil very quickly. Now, because infiltration and drainage in the soil are slow, it is common to find saturated soils and occasional ponding following heavy rainfalls as water slowly infiltrates. Topography and slope position, which can be extremely subtle in North Dakota, influences the movement of water on the landscape. In a traditional sense, drainage and then ponding are a function of topography, which can depict the locations that may be more consistently wet or dry. Low topographic relief encourages high soil saturation, which in many North Dakota soils causes an accumulation of dissolved salts. Now, this is frequently seen as white surface salt crusts that are left behind as the water evaporates. Now, it can be seen in the aerial image on this slide that the salts have accumulated in many of the depressions and around the edge of the water bodies. This emphasizes the need to plant in locations that experience the least ponding and may be considered topographically to be the shoulder or back slope positions. The summit is also commonly a good planting position, but this depends on the gradient between the maximum and minimum elevation. If that difference is very small, say 1 to 2 feet, then that may not be enough to avoid transient salts in the rooting zone. It all depends on the planting site in relation to the larger landscape. Unless you are planting a species that is very water tolerant and intended to be in the water, all plantings should avoid being anywhere near the foot or toe slope in very flat terrain to prevent from being planted in soils that are too frequently wet and have the potential to accumulate salts. Major Land Resource Area 55A, which encompasses Devil's Lake, has the classic soil characteristics that develop from low rainfall and low topography. The fine-textured glacial till and lacustrine soil has the expected moisture holding capacity and salinity issues that challenge tree growth. In landscapes with more precipitation and topography, salts and fine-textured mineral soil components are readily leached lower into the profile or away from the site. 39 million acres of North Dakota's landscape is recognized as having high salt content, encouraging transient soluble salts in the soil profile. These dissolvable salts accumulate in depressions and in some high slope positions when the water carrying the salt evaporates. The presence of these salts in the rooting zone limits the availability of water for plants by altering the osmotic potential, decreasing the water movement into the roots. The consequence for vegetation is hydraulic limitation, which displays symptoms of slowing growth and growth increment through time. Salts are also correlated with high soil pH, limiting the availability of some nutrients to the vegetation. One of these nutrients is iron, which commonly produces a yellowing foliar symptom in landscape birch and maple trees. There is no long-term solution for iron deficiency in basic soils. These two criteria combine to influence two of the three fundamental resource needs for all vegetation: water and nutrient. Most nutrient deficiencies associated with high pH do not cause visible problems with trees, but they do affect overall health. We've covered the most important site considerations for planting in most of North Dakota. So now let's cover some of the related important concepts. The adaptability of any natural system to a disturbance is a function of species diversity. Disturbances are either abiotic, like climate or soil conditions, or biotic, like insects and disease. All of these disturbances encourage an ecosystem to become more species and structurally diverse. The next important concept, which has been briefly discussed, is resource availability. Available light, water, and nutrients will depict the health of individual trees in any growing circumstance. Maintaining an adequate accessibility to these resources is fundamental. Limiting competition between planted trees and any other present vegetation makes water, light, and nutrient available for favored trees and other plants. Any planting should consider both age and species diversity, which naturally emphasizes variability in structural components. Integrating species and age diversity helps to limit loss or decline when stressful circumstances or disturbances occur. Diverse groups of species further increase the likelihood that an abiotic or biotic event will not affect everything equally. Applying this idea guides us to think about seeing plantings as a work in progress, which helps focus on periodically planting trees over time and performing intermediate activities like thinning, as was mentioned earlier. Periodically planting new trees is a good approach for landscape settings, but is not a concept that is frequently associated with windbreaks. A similar windbreak approach would be renovating by removing declining trees and planting new ones to increase overall health. Planting different varieties of a species is also a diversification method. Subtle genetic variation within a species emphasizes different functional traits and introduces an adaptability to a variety of conditions. One of the constant recommendations I make during forest health requests is to control competing grasses around trees, ailing trees or healthy trees. We've discussed the necessary resources of light, water, and nutrients that will determine whether or not a planting will be successful. But every site has finite resources, so there will be competition for those resources. Specifically, grass, which is a tremendous competitor for water, can have a large impact on tree water use. The best practice to deal with competition from grass is to make sure that grass near a newly planted or young tree is eliminated from consuming the water resource. And usually I suggest mulching. I think it's pretty common to hear that people are suggesting mulching as the best landscape solution for eliminating grass. Removing the grass around the base of the tree is important to eliminate that competitive advantage. And I say advantage because grasses don't just use the precipitation that falls, they intercept a certain amount from every rainfall before it can even get through the grass and the grass root system down to the tree root system. So another way of eliminating grass that's more common for a lot of windbreak plantings is a weed barrier fabric. The weed barrier does not break down as advertised, and I think we've seen that in a lot of cases, and it is a common problem. And trees growing through a cut in that fabric will require more of an opening as they grow, of course. It is common to find that trees showing symptoms of drought or general decline are actually being girdled by the small hole that was cut for the seedling at the time of planting. Cutting those holes as time elapses is extremely important for planting success. So regardless, in North Dakota, effort needs to be made to assure that everything is done to maximize the amount of available water to the tree, particularly for the first few years. But as the tree grows in size, it increases leaf area and will require more water. After considering some of the more difficult site conditions for growing trees, it now becomes important to consider what species may do better on your site. There are a few lists of species that you could look at to choose what may be most successful for your particular location. For much of the eastern half of North Dakota, this means you need to be considering soil salt tolerance and high pH, which is a difficult set of variables for trees, since the vast majority of trees have not evolved to these conditions. Choosing a species based on the relative plant hardiness zone and then addressing the soil characteristics is about as good as we can get. Once you've selected the location on the landscape and your planting objectives, you should select species that fit the site conditions. As we've been discussing, this needs to address the subtle slope variables, focused on those positions that best define the shoulder and back slope in a landscape that is topographically poorly defined. When salts are present, the tiny variation in slope can play a very important role in tree mortality. If trees are already on the ground, then care and maintenance become the most important activities to attend to. Competition must be managed, and maximizing water and light is fundamental to their successful establishment and continued growth. Addressing site conditions for new plantings or simply tree health conditions is likely to become more difficult in the future. Future climate conditions are expected to increase the potential of extremes in climate, which will require trees to tolerate a large variation in conditions over a short time frame. We are very likely to see a shift in the timing and distribution of rainfall, as well as large swings in temperature. It is already appearing that we are more frequently receiving heavy, short-duration rainfall when historically it would have been longer soaking events. Some expected climate changes are decreased growing season precipitation, which will encourage a lack of photosynthesis and tolerance for additional health challenges, or short, heavy rainfall events causing pooling, drowning, or accelerated runoff from slow water infiltration rates in fine-textured soils. Also increased summer temperatures, which will increase the rates of transpiration and atmospheric demand for moisture, as well as increased winter temperatures, which can cause transpirational water loss in conifers, leading to a higher instance of winter burn or foliar injuries. A changing climate will likely make it more difficult to support tree growth if we continue to see moisture come outside of the growing season. This leads to less productive and healthy trees that are unable to withstand the presence of secondary health issues like insects and disease. Likewise, increased temperatures lead to more atmospheric demand for moisture from the leaf surface. This will cause trees to develop more tension in the water column between the root and the leaf, which means there will likely be an increased occurrence of closed stomates, which reduces photosynthesis. The ultimate outcome of all these scenarios is increased health issues and instances of secondary health issues.